Okay, so this is the last video of new stuff we're going to learn this week. I think I might film a video, like literally a couple minutes, putting it all together. But today we're learning about quotient of powers property. So quotient means divide, whereas the last one was product of powers, so that's when we're multiplying. Okay, so in this lesson, page 72, let's say we had 4 to the 5th divided by 4 to the 2nd. Okay? So 4 to the 5th, let's think about it. Let's expand it. That's just 4 times itself 5 times. 4 times 4 times 4 times 4 times 4, 5 times. Divided by 4 times itself 2 times, 4 squared. Okay, so we know that when they're being multiplied and they're like in a fraction, so they're being multiplied in the numerator, being multiplied in the denominator, and the fraction means divide, you can just cancel out if they're the same number in the numerator and the denominator. So that leaves us with just 4 times 4 times 4 in the numerator. There's just a 1 in the denominator. You don't even need to write that. Okay, yeah, it's over an invisible 1. You don't need to write that. Everything's over an invisible 1. So this is the same as 4 times itself 3 times, so 4 to the 3rd. So the rule that we're learning today is quotient. I haven't used that word in a hot minute. Quotient of powers rule or property. I wish I wrote property on my other notes. Oh well. Alright, so what this rule says, right? When you divide powers, so we're dividing powers, 4 to the 5th is one power, we're dividing it by 4 to the 2nd. So when you divide powers with the same base, crucial, with the same base. So when you divide powers with the same base, all you do is you just subtract the exponents. So, literally, I'm going to rewrite the problem that we started with and show you it with this rule. So, i.e., for example, if we have 4 to the 5th over 4 to the 2nd, all you do is you keep the base, 4, and you subtract the exponent. So 5 minus 2. So it's just 4 to the 5 minus 2 is 3, which we just proved up there. Okay? If you're going to do it with letters, because sometimes you'll see it with variables, you'll see like a to the m over a to the n. So same base being divided, 2 powers. So it's just a to the m minus n. Okay, so that's the last property we're going to learn this week. So let's just do some practice problems. So example A, 4 to the 8th divided by 4 to the 3rd. Okay, so quotient of powers property. When you're dividing powers, we're dividing 4 to the 8th by 4 to the 3rd with the same base. They both have the base of 4. Just subtract the exponents. So this is the same as 4. Well, let's subtract the exponents. So 8 minus 3. So it's the same as 4 to the 5th power. Okay? Example B. 6 to the 4th over 6. So we're still dividing two different powers. 6 to the 4th This 6, what's the invisible exponent? 0 or 1? 1. It's always an invisible 1. That's 6 times itself one time. If it was to the 0 power, that's totally different. Anything to the 0 power equals 1. So just know the invisible number is always a 1. So 6 to the 4th divided by 6 to the 1st equals 6 to the, subtract the exponents. 4 minus 1. So it's 6 to the 3rd power. Example C. B to the 10th over b to the 6th. Try it on your own. What is it going to be? What's it going to be? It's going to be 10 minus 6 is 4, b to the 4th. Example D. What if we have x, 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 x over x? All right, well, same variables in the numerator and denominator. Cancel out an x, cancel out an x. That leaves us with 1, 2, 3, 4, 5. 5 x's in the numerator. X times itself 5 times, that's x to the 5th. Let's try that again with the variables. With like changing it from being multiplied to exponents. So let's say we have 3 times 3 times 3 times 3 times 3 divided by 3 times 3 times 3. So first, you cancel out. We have 3 divided by 3 is just 1, so we don't need it there. 3 divided by 3 is 1. 3 divided by 3 is 1. Okay, so we have 2 3's left in the numerator. We have 3 being multiplied by itself twice, so 3 squared, which we know is 3 times 3 or 9, but we're trying to practice writing them with exponents. Example F. So let's say now, because sometimes you guys see them where they have the equal sign. So 13 to the 5th divided by 13 to the x equals 13 to the 4th. Okay? So, the right side, we can't do anything with that. We're leaving it like that. The left side, we can incorporate or implement the quotient of powers property. So that's the same as 13, same base being divided, so we subtract the exponents. 5 minus x equals, and then bring down 13 to the 4th. So when they have the same base, and we're trying to figure out what's going on with these exponents, just eliminate the bases for a little bit. So let's say we're doing 5 minus x equals 4. I just brought down the exponents and I'm not even worrying about the bases, the 13s. So now it's a one-step equation. Actually, it's a two-step. Box up the variable, draw the line. So first we have to get this positive 5 over there. What's the opposite of positive 5? Negative 5. So negative 5 on both sides. Subtract 5. 5 minus 5 goes away. Bring down, this is a negative x, guys. That minus sign is a negative. 4 minus 5 is negative 1. Okay? Divide by negative 1. Cancels out that negative. Divide by negative 1. X equals negative 1 divided by negative 1, positive 1. You can always plug it back in and check. Okay, so let's check that. 13 to the 5th over 13 to the x, well, we're saying x is 1, equals 13 to the 4th. Let's see. Same base being divided, so let's just subtract the exponents. Is 13 to the 5 minus 1, 13 to the 4th? Well, 5 minus 1 is 4 indeed, so yes, that works. That makes us happy. 2 more examples, and then we're actually going to be done with this concept. There's not much to it. And I'm not going to add on other rules to this video. 11 to the x over 11 to the third equals 11 to the second. Okay? So let's look at the left side. We have a quotient of powers property going on. We're dividing. They have the same base, 11, so we subtract the exponent. So that's 11x minus 3 equals 11 to the second. Okay, well, what number minus 3 equals 2? So let's just forget about the bases, the 11. Let's just bring the exponents down to solve. So we just brought the exponents down. X minus 3 equals 2. Box it up. This negative 3 needs to go to the right side, so add 3. Add 3. X equals 2 plus 3 is 5. Let's check it. Is 5 minus 3 2? Yep. Sure is. Last example. Z to the 7th. I like to put the line there for math, so I don't think it's a 2. Over z to the negative 14. Same base, being divided, subtract the exponents. So it's z to the 7 minus negative 14. Don't let that trick you. Minus negative touching becomes a plus. So that's the same as z to the 7 plus 14 is 21. And that's it, guys. That's the quotient of powers property. When you're dividing, quotient means divide. When you're dividing powers and they have the same base, write the base, subtract the exponents. Bada bing, bada boom.